Well, before we look at the general formula for computing the future value of an annuity, let's go back for just a second, back to the previous video, when we came up with a formula for adding up these 5 terms. And the formula looked like this. Well, I'm going to take that one more step because it'll look more like the general formula. A is equal to, notice this numerator has 1,000. Both of the two terms have 1,000 as a factor. I'm going to factor that out. 1,000. And then what I get is 1.07 to the 5th power minus 1 all over 0.07. Our new formula is going to look much more like this. Remember, this 1,000 is the amount of the periodic payments. This 5 is the number of times it's compounded. This was 5 years compounded once per year. And what is 0.07? The 1.07 here is 1 plus the periodic interest rate of 0.07, and this is the periodic interest rate of 0.07. That gives us the general formula here. From the above problem, which we just looked at again, we obtain the following formula to compute A, the future value of an ordinary annuity. So remember that payments are made at the end of each period, just like a car loan. You'll pay it at the end of the month. A is the future value. R is the periodic payment. So let's write that down. Actually, I think I have most of these written out for us. A is the future value, or the amount, that's what A stands for, the future amount of the annuity. R, capital R, is the amount of each periodic payment. And we're going to have several formulas and memorize that. Capital R is always the amount of a periodic payment. N is the number of periods. It doesn't necessarily mean the number of years, but it would mean the number of years if you're only compounding it one time per year. And then I is the periodic interest rate. It is the annual interest rate divided by the number of payments per year, or the number of times that it is amortized per year. So if it were a 10% annual rate, R would be 10%, or 0.10. And if it were compounded quarterly, then M would be the number 4. So it would be 10% over 4, which would mean 2.5% each quarter. All right, so let's look at an example, and we're going to use this formula. Ian invests $1,000 at the end of each year into an ordinary annuity that pays 6% per year compounded annually. Okay, before I move on to that, let's label what all of these numbers represent to us. He invests $1,000 at the end of each year. So this is our periodic payment. That's capital R. Into an ordinary annuity that pays 6% per year. That means little r is 0.06. Compounded annually, that's only one time per year. So M is equal to 1. How much will he have at the end of 15 years? Well, I don't know if we need it, but we can say T, the number of years, is 15. All right, well, all that's asking for, how much will he have at the end of 15 years? Find the future value. Find A. And here's the formula. So all we need to do is say A, the future value, is R, which is 1,000. And then, in the numerator, what is 1 plus I? I haven't written down what I is. I is R over M. It's the annual rate divided by how many times it's compounded per year. So in this case, I and R are the same thing because it's only compounded one time per year. So that would be 0.06 divided by 1, which is just 0.06. So 1 plus that is 1.06. Raised to the N. What is N? How many payments are being made? Once per year for 15 years means N is 15. Minus 1, and the denominator is just I, which is 0.06. Okay, so that is actually the value, but we need to plug it into our calculator. Let me do that now. All right, so I'm going to do 1.06 raised to the 15th power, and then subtract 1. And then I'm going to divide that result by 0.06, and then I'm going to multiply that by 1,000. And I'm going to get 23275.97. So that's dollars. This is A, the future value of that annuity. And let's see if it makes sense. Well, he's investing $1,000 a year for how many years? 15 years. So he's putting in a total of $15,000 in payments. And this seems certainly reasonable that 15 years later, remember that first payment is going to get compounded interest how many times? It's a trick, not a trick question, but it's not 15 times, it's one less than that. Because when you first put the $1,000 in, it does not get any interest. It's the next year where it starts getting the interest. So that seems like a perfectly reasonable number. All right, one more example for this video. How much money will you have when you retire if you save $50 a month from graduation until retirement? And we'll define what that means right now. Assume you begin your investment at age 23 and continue until age 70. What we care about is a total of 47 years. And the interest rate averages R equals 0.042. That's your annual interest rate, compounded monthly. So if it's compounded monthly, that's 12 times per year. So my periodic interest rate is 0.042 divided by 12. That's how much interest you're going to receive each month. 0.042 divided by 0.12 equals, looks like 0.0035. Let me make sure I got the decimal in the right spot. 1, 2, 3. 3%. I'm going to double check. 0.042 divided by 12. Oh yeah, I divided it by 0.12 last time. That was the problem. So yes. Okay, so this is really, it's not even 1%. It's 0.35% per month, which if you multiply that by 12, you're going to get 0.042. Okay, so T would be 47 years. And what is our M going to be? Looks like I didn't give a place for, I'm sorry, N, the total number would be, total number of times that, total number of $50 deposits. That's going to be 12 per year times 47 years. And let's see what that is. 47 times 12 is 564 $50 payments. Okay, I is 0.0035, and R is the amount of the periodic payments. That's 50. All right, so what is A? Let me rewrite the formula here. It's R times, in parentheses, 1 plus I raised to the N minus 1 over I. For us, that is 50, that's R, times 1 plus I would be 1.0035 to the n, which is 564, that's a big exponent, minus 1, all over I, which is 0.0035. So let me plug that into the calculator. I'm going to do it as 1.0035 raised to the 564 power. Then I'm going to subtract 1. Then I'm going to divide by 0.0035. And then I'm going to multiply by 50. And that will give me 88,209.24. So that's not bad. For only $50 per month. Yes, you're doing it for 47 years, but using the interest rate given, 4.2% annual interest compounded monthly at this rate, you would have $88,209.24 for retirement.